Alright, so in this video we're going to be writing equations of lines given just a point that's on the line and the slope of the line. And I'm going to show you two different methods for doing this. One uses something called the point-slope equation, and one of them uses the slope-intercept equation. So I'll do a set of problems that first uses point-slope, and that's going to be the first set, point-slope. Okay. And then I'm going to do a set of equations that uses slope-intercept. Point-slope is just another standard form for a line. I shouldn't say standard because there's a standard form, but anyways, it goes like this. Y minus k equals m x minus h, where h and k come from the point and m is the slope. Man. And you just fill in the blanks, just like slope-intercept. So here, it's going to be y minus, that's a negative 2, so it becomes plus 2 minus a negative. M is negative 3/4, and then we've got x minus our h, which is 4. And technically, you've just done it. You're done. You don't have to do anything more. But you're going to want to put it into slope-intercept form because it's not really useful in this form. So what we'll do is we're going to start by just doing some distributive property over here. Y plus 2 equals negative 3/4 x minus, see, negative 3/4 times negative 4 is a positive 3. Then we're going to subtract 2 from both sides. Y equals negative 3/4 x plus 1. And there's our equation. If you want to double check, you can always go back and substitute these values in here for x and y and see if you get a true statement. You should. Alright. So here's now, oh, this one's a little bit different. Undefined. If you have an undefined slope, your equation is always going to be x equals something. And the something it's going to be equal to will be the same x as you have here. So it's negative 5. And the reason why, think about this, here's this point, negative 5, negative 2. Okay, undefined means it's a line that just goes straight up and down, so it's like this. So it also passes through the point negative 5, 0. That's its y, or its x-intercept. So it's the equation x equals negative 5. If you have one where the slope is 0, I don't think we have any like that here. But if you come across slope is 0, 0 slope, write this down. Horizontal line, y equals something. Okay. Alright, moving on. So let's see here. We've got our h, we've got our k, we've got our m. So we're going to say y minus h equals, oh, that's k, minus k equals m x minus h. So let's go ahead and fill in the blanks here. We have y minus 1 equals negative 1/7, x minus a negative 2, which makes that plus 2. Y minus 1 equals negative 1/7 x minus 2/7. We're going to subtract 1, or add 1 to both sides. X. Let's see, we're going to add 7/7, which is going to give us a positive 5/7. Let's see. Next, okay, we've got our h, we've got our k, we've got our m. Y minus k equals m x minus h. So we've got y minus 0 equals 1/2 x minus 4. You just take away the minus 0, equals 1/2 x minus 2. Which is our distributive property. We save ourselves a step there. Done. Here we've got h, k, m, y minus k equals m, x minus h. So y minus a negative 4, which makes it plus 4, equals m is 3, x minus a negative 4, so that's also a plus 4. So y plus 4 equals 3x plus 12. After we do distributive property, take 4 away from each side. Y equals 3x plus 8. Okay. Next door, y minus k equals m, x minus h. This is our h, this is our k, this is our m. Fill in the blanks. Y minus a negative 2, so that's plus 2, equals 2. X minus a negative 4, which is a plus 4. Y plus 2 equals 2x plus 8. Take 2 away from each side. 2x plus 6. Alright. So, as just a recap, the point-slope equation is just a different form of the equation that's just kind of used for this purpose. So you've got y minus k equals m x minus h. It's just like y equals mx plus b. Here the m and the h and the k, you just fill in the blanks to get your equation. Your h and your k come from the x and y coordinates of your points. Sometimes you'll actually see this like y minus y sub 1 or y sub a or something like that. But I like this h and k thing, that's just me. And then your slope is given to you there. Just fill in the blanks. I think I'd do a little bit of work to turn it into slope-intercept form because the equation is more useful in slope-intercept form. Okay. Speaking of which, take a look at doing this with just slope-intercept form. Okay, so if you have your, these are all going to be in slope-intercept form. Okay, so you know your slope-intercept form is y equals mx plus b. Okay. Now, if you know the slope of your line, right, you know the m part already. What you don't know is the b. If you think about it, you know, your slope, it's like negative 5/4. I guess that's, well, from your point of view, I guess that works. Yeah. So anyways, your line has a certain steepness, but you don't know where it is on the y-axis. Is it up high? Is it down low? Okay, but there's only one height above the axis that's going to work to make it pass through this point right here, 4, -2. So if you kind of like sketch this out, here's this point, 4, -2, 4, -2. With a slope of negative 5/4, it's going, actually this is a pretty good one here, because this means it's going down 5 and forward 4, or up 5 and back 4, which would actually land it right at the point 0, 3. Okay, so this line has a slope of negative 5/4, so it goes down 5/4, down 5/4. Now, just knowing that, knowing the slope, doesn't tell us necessarily that it passed through this point 0, 3, but if we know it passes through this point, we can kind of work backwards and figure out where it crosses here. A pretty common method for that is, well, if we're going to have a full equation, it's going to be true. It's a true statement about every coordinate pair on that equation, so, or on that line. So for example, the point 4, -2, I should be able to plug that in for x and for y, and then I plug in the slope and the y-intercept for that particular equation, and then I get a true statement. So what I need to do here is I'm going to plug in this x and this y along with that slope, and figure out what b gives us a true statement. So in this case, I'm just filling in the blanks, x, y, and our m. So I get -2 equals -5/4 times 4 plus b. Okay? So I've got the coordinates -2 and 4, or it be 4, -2, and the slope. And if this equation is going to be true, there's only one value of b that's going to work for it. And that's what we're trying to figure out, which value of b makes this equation work for that point. So we'll solve it. -2 equals, let's see, this is -5 plus b. We'll add 5 to both sides and we get 3 equals b, just like we expected. Then we just write out our full equation. Y equals -5/4 x plus 3. Now we know that if I were to take the point 4, -2, and I substitute 4 for x, -2 for y, I'll get a true statement. This equation works for that point. And we were looking for an equation that would work for that point and that slope. Got it. Next few examples I'm going to go a little quicker. Okay. So to make it just in kind of a method, this is our x, this is our y, this is our m. We say y equals mx plus b. We substitute things in here. 1 equals -5 times -1 plus b. 1 equals 5 plus b. Subtract 5 from both sides. -4 equals b. And then we go to write out our full equation. Y equals -5x minus 4. So we found the b we were looking for. Alright, so here we've got a particular point xy. We've got our slope. We just have to find the b. So I'm going to go -4 equals -1 times 3 plus b. -4 equals -3 plus b. Now we're going to add 3 to both sides. -1 equals b. Now we have our b. We just write our equation. Y equals, we've already got the m, -1x. We're not going to put the 1 in, minus 1. There's our equation. So this is pretty quick. Let's see. So we have our x, we have our y, we have our m. -5 equals 5 times -2 plus b. So we filled in one of our points we want it to be true for, and we filled in the slope we want it to be true for. Now we just have to find the y-intercept. So -5 equals -10 plus b. Add 10 to both sides. 5 equals b. So that's the b we're looking for. So our equation must be y equals 5x plus 5. Okay. Here, our slope is 0, and this is a special case that can save you some time. Okay, a 0 slope means that it's a horizontal line, and if it's going to pass through the point 4, 0 and be horizontal, then it must pass through the the point over here as well, 0, 0. And so that equation, and for a 0 slope line, 0 slope horizontal line, okay, it's going to be y equals something. And in this particular case, the equation is y equals 0. By the way, this line is also known as the x-axis. So here we have, let's see, 1 equals our m, this is our x, this is our y, this is our m, -3 times 3 plus b. 1 equals -9 plus b, add 9 to both sides, 10 equals b, so y equals -3x plus 10. Pretty easy. So there you got two different methods to use for this. You can use the slope, the point slope form equation, y minus k equals mx minus h. And then you just fill in the blanks with your point and with your slope. Right? Pretty straightforward, and then you just have to do a little bit of math to turn it into slope-intercept form. I think this is probably about the same amount of work either way. For this one, using slope-intercept, so you've got your equation, got your equation here, y equals mx plus b. You want this equation to be true for this slope and that point. So you fill in the slope, you fill in the point, and you got to figure out what b or what y-intercept will make that happen. And so you solve for b. Once you've done that, then you know that it's just y equals, you already have the slope, and you just fill in the y-intercept. Well, good luck with all these.